Okay, so, oh well, sorry for that. Before I get started, today we're going to talk about databases. Any questions? So there's a question about the sort of the format for the final project report. We're still finalizing it. Hopefully I will announce it by the end of today. The main idea is that for the final project, everything is submitted through a Jupyter Notebook. So you should, there's two things. One is a Jupyter Notebook, and one is a 3-minute video. So you can describe your project. If you don't know how the video should looks like, you can go to our course and go to the Hall of Fame. There is multiple project video from previous years that you can take a look, and hopefully that will inspire you to create your video as well. And here, for example, some of those previous projects, let's say 2016, they have this specific Jupyter Notebook, and then this can give you a little bit idea of what we're looking for. And roughly speaking, our project is going to have those sections. So background motivation, objective, data, the pre-processing, the processing of the data, exploratory analysis, including analysis methodology, and so on. So more analysis, those are detailed analysis. This is analyzing asteroids, but let's see. And then after analysis, you can talk about, in our current format, it's going to have a summary of, this, like a few sentence summary of your project. So if you want to get a sense of how the videos looks like and how the previous Jupyter Notebook looks like, please go to the Hall of Fame webpage. Any question before I start database lecture today? Okay. There's another development. We know that the last homework is due this Friday, but we give you 1-day extension without penalty. So if you want to submit with penalty, the last day to submit it is next Monday. The project, final project, I believe is due on, let me think, 22nd. No, actually, the Friday of the 22nd. 22nd is the Sunday, and the Friday, actually, sorry, it's a Friday of, I believe it's the 20th. It's the 22nd? Okay. Which one is Friday? 22nd is a Friday? Oh, okay, all right. My calendar is off by exactly 2 days. Okay, good. All right, so let's get started. So today we are going to talk about database. How many of you have ever used database? You can raise your hand or raise your hand remote. You can get a sense. So database, of course, by itself is a class, right? We will spend, I could spend an entire semester talking about database. And pretty much I'm going to give you a taste of database in one single lecture. In most cases, the database you're dealing with are called relational database. There's many other database types, but right now let's talk about this more traditional one. And in most cases, when you're dealing with database, it's pretty much hidden behind. You don't directly have access to all the things inside the database. And the most common way for you to access it is through API. So one example could be if you go on Amazon and you are trying to buy a certain textbook, you type in a textbook title, and then there's a search function on the website. What's behind it? The search engine is operating over a really large database. And when you find they rank the entries that are coming out of the search and then presenting on the web page. Okay. So let's, for simplicity, look at a very simple relational database. So this is, in a sense that you could think about it's a collection of tables, which include entities, and then there's relation between the tables. So here is a very simple table that describes purchase history. Oh, by the way, in most cases, the organization is managing a database. For example, Amazon manages its own database. Twitter probably manages its own database, and so on. So today we're just going to have the most simple form of database, which is actually stored as a text file in your in the directory of lecture 28. So let's look at this purchase history. So Jack Black, the customer, bought a MacBook Pro, and he lives in San Francisco, and spent $2,700. And he also bought, a HDMI connector, and also bought a USB-B connector. So if you look at this, it stores all the information I want, but the drawback of it is that there's some duplications that is happening. For example, the customer name and the customer address is stored 3 times because each row is a purchase history with respect to a specific product. So if you actually do this, and if multiple customers purchase the same items, or maybe there's information on the product, all those are duplicated in the storage system. So the idea, one of the motivation to have a database system is to try to separate this information in this table into multiple meaningful tables. For example, if I look at this, a direct intuitive way of thinking about it is maybe I should have a table that contains information surrounding the product. For example, the name of the product, the price of the product description. And then I should have another table that just stores customer information, right? The name of the customer, the address, and so on and so forth. And then there might be a third table that's going to connect those two, which is saying which customer bought which product, and then additional information for that transaction, for example, the data purchase. Now, if we do that, this is how it looks like. So again, in this case, I'm going to have customer name, customer address, any other customer information in what's called a customers table. And then to help me access those information, I'm going to assign CID, which is customer ID. Similarly, I'm going to break my information into a products table. Again, it's product name, price, product descriptions, and maybe manufacturer and all the other information you can attach to a product. And it's going to have a product ID. And in those cases, the CID and PID are what's called primary key to the table. And the idea is that if somebody provides this ID, it will uniquely determine a specific row in the table. Now, in order to complete all the information, finally, we're going to have what's called transaction table. And this is a table that is just describing the transaction by connecting the primary keys from the other 2 tables. So in this particular case, the customer ID, CID, the product ID, PID, in this transaction table are now called the foreign keys. The idea is if I actually look at the transaction table, the TID is going to be its primary key. And for each of the primary key, I can query a specific row of my transaction. And then I have access to specific PID and CID, which we can then use to query the product table and customer table. So now what is convenient in this specific way of storing my data is that if the customer want to update its address, for example, in the naive way of storing, if a customer update his address, he would probably need to update all the customer address in all the rows, where in this particular case, if the customer just update his address, you only need to touch one of those tables, which is a customer table. All right. Of course, there's many additional advantage of using a database, but this is a very straightforward one. So when you think about a relational database management system, basically that support 3 types of operations: read, write, and update. And of course, there is other operations such as create, delete tables, and then table join. We're going to spend quite a bit of time today actually looking at table join, which is one of those most interesting sort of operations for database systems. In fact, if you're not careful in designing your join operations, you might actually incur a very inefficient queries. So there's actually a lot of database research that goes into how to optimize a joint operation between tables. So to access a database, we use SQL, and it's a short for structured query language. So it has a specific syntax, and we're going to go over some of those more fundamental ones. There is sort of this online thing here where you can actually go over the entire, SQL lecture. But we're going to use a few very basic ones. And it's actually fairly straightforward to read, especially for the simple ones. For example, when I say select star from products, the star means I'm going to select all the entries or all the rows from the table. That's called product. But also, once I select some rows from the table products, I can also put a filter, which is putting a condition. And then this condition says where price is bigger than 100. And price is the column name. So what does this mean? This means that return me all the product whose price is bigger than $100. So those are some very simple ones. Now, we are going to do today is we're going to focus on SQLite, depends how you pronounce it. There's many different sort of database out there, for example, MySQL, Oracle. SQLite is essentially a database that works for a single user. And the whole database is in a file. So in our lecture today, the whole database is called the Chinook.db. We also have a backup one because towards the end of today's lecture, we're going to talk about security of the database system. And we're going to try to hack this database. And after the hack, this database is actually partially destroyed. So you need to replace it using the backup one. So it's stored in a single file. And then we're just going to do using the SQLite Python interface today. And it's a fairly easy to use system. Again, if you want to go over the detail of SQLite, there is sort of a specific tutorial here. And we are actually using their standard sample database. So let's look at it first before we go into the detail. So the sample database is a database that stores different media, which is actually albums and tracks. So this is a big overview of what's called the database schema. It actually gives you information about what tables does this database contain and how are they connected with each other. So in this specific case, you can look at, well, there's a table of artists, okay? And each artist has an artist ID and the name of the artist. And then the primary key is artist ID. The artist ID is also a foreign key to the table album, where the album ID is the primary key and artist ID is a foreign key. And the album table stores the title of the album. Now, album ID is a foreign key into the tracks table, which stores the tracks of that album. And of course, the primary ID is a track, but it stores information on the track, which are name of the track, the media type, the composer, the milliseconds, and so on. Because this is something where people can potentially purchase by track, this is linked to invoice items table, which talks about for each track, how much it will cost. And then invoice item is connected to invoices and connected to customers. And customer, of course, the primary ID is a customer ID. It's information of the name, company address, phone number, email, and so on of the customers. So this is just a general information that this particular database, which is stored in a single file, contains, roughly speaking, 6, 10, or 11 tables. So we are going to kind of store or play with this table. And there's more detailed description of each table, and we're going to see how we actually play with it. So the first thing we do to kind of query this table, we're going to import pandas, and then we're going to import the SQLite library. And in short, we're going to call it SQ. And the important comment here is called sq.connect. This means right now I'm going to establish a connection between my interface with the backend database, which is stored in a file. And then what I'm going to do is to say, select every row from the album column, and then print the first line from this row. So if I do that, the first one single row I obtained is the album ID and the name of the album. Okay. Now, of course, because I obtained everything from this album, so I can say I can use a for loop to print all the items in this table, and this is what it have. So from the second one and so on. So you can look at all the album names, and some of them are like, I don't know, I never heard of Bungo Fury. Anyway, so there is a large number of albums that you print out and so on, and all the information. Now, you can also retrieve everything at once and put it in an array of tuple. And this is what's called fetch all. And again, the double quotation mark is precisely where you are executing a SQL query. So what SQLite does is actually you can pretty much run your code by providing SQL scripts, and then it will actually fetch the content from the table and display them. So again, if I say fetch all, that means I am going to execute this query and obtain the result, and I'm going to display all the results in an array of tuples. Okay. Now, there's of course a similarity between SQL and Panda, because you can always think about Panda to also be able to handle informations from a table. But the idea is sometimes when you actually use SQL, it's actually is specifically optimized so that for certain operations, it's much faster. Okay. So this is a way actually of how to use sort of the Panda data frame to also execute SQL queries. So in this case, again, I'm selecting everything, and then dot head means that I'm going to show the top 5 rows that I just obtained. Okay, so this just displays here. The nice thing of using sort of Panda data frames is that it actually displays it in a very nice looking table than what do we show what here, which is an array of tuples. Okay. So now we can run the SQL query that we did earlier is select all the rows from this album table. Now I'm just going to select a specific column, and you just provide the column name. So again, I'm going to sort of read this SQL, which is just selecting the title column and show the top 5 record. So again, here it shows the ID. Well, actually, this is not ID, sorry. This is actually the ordering coming from the Panda data frame, but it shows only the title. But I can also limit how many rows I'm going to get. If I say limit 3, it's only giving me 3 rows. So that's what it is. We can also further restrict with this where keyword. Where, think about it as a more of a filter. So for example, this SQL query says, select all the rows from the album, but I want the title to be Let There Be Rock. And also another thing I want to emphasize is that in this SQL query, see this special format that I'm using triple quote. When I'm using triple quote, I could format the SQL query by using multiple lines, and it's actually just increase the readability of the SQL query. Later on, we are going to see queries that is more than 10 lines long. So it's nice to be able to break the SQL queries into multiple lines, where the first line says what is a general operation, and the second, which is select, and the second line, and then all the further lines talk about different kind of filtering or conditions I'm putting over this particular query. In this case, where is more of a filtering. So specifically it says, well, where title is equal, of course, there's multiple legal operations. Equal means it is exactly this title. Less than or bigger than this symbol means it's not, means that it does not match this title. And you can also use other things like bigger than, smaller than. In means that it's in the sort of potential option. Is dual, is non-dual, test by whether it's empty. So in this specific case, if I'm going to try to find the one album whose title is Let There Be Rock, it's going to return when you actually find an entry. Okay. Now, if I simply replace it to say lot, the title is not this one, then it's actually going to print out everything else. So here, remember, I'm only going to show the only 10 record. In this particular case, is showing, some number of record where neither of them has a title equal to Let There Be Rock. You can also say, okay, I'm going to select the invoice table. Remember, the invoice table is a purchase history. I want to look at all the purchases that is bigger than, say, $10. In this particular case, it's going to return everything from the invoice table. For each row, it says invoice ID, customer ID, the date. And then if you look at the last bit, the total, which is the purchasing price, all of them is selected to be bigger than 10. So again, when you are accessing a database, it's actually very similar when you are actually operating over a Panda data frame, because at the end of the day, a Panda data frame stores table and a database stores multiple tables. All right. Now I can also use this parameter called between keyword. So I'm going to select all the rows from the invoice table, and then the total is between 15 and 20. What does this mean? This means I'm going to return all the purchases who is between $15 and $20. So again, you can see that I have returned a number of purchases that is on the last column is between 15 and 20. If you want to use the in keyword, I can select everything from an invoice where the billing city is in Chicago, London, or Berlin. So this is just saying that I want to look at all the purchase history that is purchased from people who are living in those 3 cities. So this is what it's going to return. It's going to return all the customers whose billing city is from those 3 cities. So as you can see that the SQL query, the first part of the SQL query selects certain number of rows, and the second part kind of filter rows based on a specific column, or you can filter it based on multiple columns. All right. And also, Now there's a little bit regular expression. If you remember regular expression, this is like SQL equivalence of regular expression. It says select every rows from the invoices where the billing city begin with the character C. So what does this mean? It's going to come returns places like Cupertino, Copenhagen, Chicago, and so on. So all those cities begin with the character C. So this is sort of the SQL version of the regular expression. You can also say, well, instead of anything that begin with C, I want everything that end with the letter R and T from the city. If I do that, it's going to return a bunch of German cities because they like to name their city like Stuttgart, Frankfurt, and ending with the letter R and T. So this is just a fun thing to do. But the idea is, again, you can use regular expressions, and when you change the regular expression, you can match different record to your query. Now, the last bit, of course, when you are doing a database search, you want the natural capabilities of doing things like ordering. So in this case, I'm selecting everything from my album, and I'm going to order the title. And by default, it's going to order on increasing alphabetical order. So in this case, it's going to start with, or, numbers. And afterwards, it's going to start with A. In between, it didn't show. It's going to, as X, A, B, C, D, E, F, G. So that is used using this particular thing, order by title. So you can choose which column you want to order it by. You can also order by, say, artist ID and so on and so forth. So the next thing, which is a minor thing, is sometimes when you actually access a specific table in your database, the column might have a very long name. For example, in this particular case, in the table track name, it's the table track is going to have a column called tracks name. So I can just say select tracks.name from tracks, and that's it. But if I want to operate over this column later, which is what we call a join operation, sometimes it's easier for me to rename this particular column. So if I say select tracks.name as track name, that means I'm going to select this particular column from the original table, but I'm just going to replace the name of this column to be called track name. So later on, whenever I talk about track name, I really mean the tracks.name from this particular table. Okay. All right, so I'm at the breaking point where after the 5 minutes break, which we're going to return at 4:13. Well, no, 4:14. We're going to start talking about one of the most important operation for database, which is join operations. Okay. All right, I'll see you in 5 minutes. Any questions? Oh, yes.
I just have a question about the homework.
Okay.
So in this last task, when it asks how much accuracy would a naive approach achieve, would that be just like 1 in 20? Because for every article, they're going to randomly pick one of the categories at random, and then you would expect that like the accuracy would be 1 in 20.
Yeah. This is a mathematical question.
Okay. So, okay.
Yes.
Just wanted to make sure there wasn't any more code.
So pick one of the 20 category at random, right? So,
Yeah.
give me if I give you a simple example, if I were going to predict if, how to say, if you're going to, okay. So assuming everything just happened by random, and I said, what's the probability that tomorrow is going to rain or not? Right. And then you say, my prediction is going to throw a coin. Right. So it's a 50% chance.
Yeah. Okay.
Right. So the argument here is if you have a really well-behaved model, it's better than chance.
Okay.
In your prediction.
That's
That's what I'm saying, right? So So yeah, so sometimes actually this is very interesting. Sometimes you would actually see some of those published paper where they say, okay, we're having a classification. There's two class of classification. We were able to achieve, 52% accuracy, right? Then your question is that, what is your error bar? Because this is just a little bit better than random.
Yeah.
right?
Okay.
So that's my question.
And
Yeah.
then one more really quickly, just to make sure, on when we're doing the train test and split, is there a specific test size that you're looking for?
Is the problem specified? Or no?
No, I don't think so.
But there's usually a reasonable split, like 20-80 split, 25-75 split,
Okay.
and so on and so forth. So if you use a more sort of, like those typical split, if there's no specification, then you can use, the sort of more normal split between those.
Okay.
Yeah.
Awesome. Thanks.
Okay. Okay, I have 2 minutes.
And my question is really quick, so.
Yeah.
So, this wasn't flagged as an issue before, so I don't think it will be now. But I noticed in the project requirement, it said to consider multiple data sets. And with our project, or the one I'm working with, it's very specific to this. As in, I only could use one source of data. Is that fine?
Did you run this with the TA? Did the TA?
Yeah, he didn't have. any
Okay.
issues with
Then
this,
that's
so-
fine. As long as, so, I mean, I think one of the reasons why we say multiple data sets is we want the project to be complex enough.
Okay.
Right?
I
If
have
you
data.
can, yeah, if you can if you and your team can convince us that your data is complex enough, that you're doing enough interesting things, we wouldn't be enforcing it.
Okay.
Especially at this stage of the project.
Yeah.
Right, but you need to kind of carefully convince us this is a complex enough data set
Okay.
for you to perform enough sort of analysis and visualization potentially.
I'm not having trouble with it. I just.
Yeah,
Okay. As
that's
long
fine.
as that's not an issue.
Yeah, yeah, okay. Okay, so let's resume. So on the high level, join tables are fun. Okay, if you like databases, this is sort of one of the first operations. You're like, okay, I am actually picking up information from one table, pick up another information from another table, and I'm creating new tables. And in fact, whenever you're doing some sort of queries on most of the website that is supported by database systems, it's doing a lot of different join operations when you're sending over some query, okay? So we're going to start with what's called inner join, okay? So, and again, let's start with looking at the data we're going to try to join together. So first of all, I'm going to look at the track table. And then this is just an example of the first 5 rows of the track. So for each track, it has a track name. It has a corresponding album ID, and it has information related to that track, like composers and how long that is, and then the price you're going to pay if you are going to purchase that, less than $1, which is actually a really good deal. Now, you can also read from the album table, which basically contains the title, an artist ID, and the album ID. So if you actually look at those tables, one of those ID that is shared between them is actually album ID. So the primary ID in the track table is track ID. Album ID is a foreign key. And album ID here is a primary key in the second table. So because it appears in both tables, this is a relation you see before, is that in tracks table, the primary ID is a track ID. In album table, the primary ID is album ID, but album ID is also in this particular symbol right here, a foreign key, or there's primary key and a foreign key. It's a foreign key in the tracks table. So the idea of an inner join is to merge the table based on this primary key, foreign key relationship. So specifically in this case, I'm going to try to merge the table using the album ID because it's a primary key in one table and a foreign key in another table. So the SQL is going to look as follows. First of all, we're going to select from album table. And specifically from the album table, we're going to select track name, which we're going to call it track. The album title, which we're going to call it album. This is sort of the first part, is I'm just selecting 2 columns from the tracks table. And then the syntax says inner join. And inner join, the second part here is a second table. And in this case is album table. And the idea is I'm going to join when the sort of the keys agree, where in this case is the album ID from which is a primary key in the album table, which is equal to the album ID in the track table. So what does this do? This now created a new table where it selected the track ID and track name from the tracks table. And then you select the album's name from the second table. So what you can see here is to say, well, this album here has multiple tracks and it has a track ID. So what you just did is actually selecting some columns from the first table, some column from the second table, and as long as their IDs agree, their album IDs agree, we're going to put it into this new table. And that's what this table looks like. And this is called inner join. So let's look at this carefully. You first selected some columns from the first table and you rename this column. So this is from the tracks table. And then we're going to join the second table on the condition that the album ID has to agree. And then the join is basically based on this equivalence relation that is highlighted right here. So in this specific case, we're doing what's called inner join. So there's many other joins, but inner join is essentially try to match the data exactly as what we specified. It only returns the rows from both tables where this condition is satisfied. Let's make it slightly more complicated. We are now going to join 3 tables together. We're going to select from the tracks table, the column track, the track name, the album name, or the album title, and then the artist name. Then I'm going to select the album from the album table so that the album ID will match the corresponding track's album ID. That is what we have done already. But then in addition, I'm going to join with the artist table because remember the artist table is related to the album table through the artist ID. So now I'm going to also match against the artist table so that I can display the artist name. If I should do this, now I have actually expanded the new table by actually creating the last column, which is artist name. And this column is coming from the inner join operation with artist table. So essentially now I did 2 join operation, combined column information or selected column information from 3 different tables. Okay. For example, here, all those songs are sung by AC/DC and so on. Now, the last bit we can do once we join all those information in creating this new table, that is track, album, and artist, we can also do those filter operation or using where condition. So the last line we add is I want to look at only the ones related to Rolling Stone. So where the artist name is Rolling Stone. So in this case, I'm just filtering it. So now you can see the table only shows the track, the album, and then the artist is only Rolling Stone. So you can do a lot of things using the join operation. Now, Because there is inner join, you could imagine there's different variation of the join that does something slightly different. So inner join only returns exact matches. So for example, in this case, if I have a simple artist table that has 2 artists and a track table that has 2 tracks, if you actually look at this particular case, when I do inner join between those 2 based on the artist ID, you can notice that the actually specific artist here does not have a specific track listed in the second table. So it doesn't find any matches. So in this particular case, when we actually inner join those 2 tables, you're only showing the things that are coming from the specific artist here, because this artist doesn't have any information. Oh, I didn't want to do that. So now, if we actually do this, oh yeah. So now, if we actually use left ID, left join, the left join really what it does is actually, if the first table didn't find any matching, it will still preserve that column, but would just make that particular column empty. So as we see before, if we actually do our previous join operation, but using left join instead, what you see is that there might be some artists that don't have any album. So after the left join is going to say, well, I didn't really find an album ID that matched this artist, so I'm just going to put it empty. So the left join idea is when I'm joining the 2 tables, sometimes when I don't find matching, I'm going to keep the information coming from the left table. That's why it's called left join, because the left table in this case is artist table. Okay. Correspondingly, you have right join. But you can imagine you can simulate right join by calling the left join, but just switching the order of those 2 tables. So actually in SQLite, they don't really implement the right join. It's kind of, you can kind of emulate it by using left join. There's many other joins. There's also what's called outer join and so on. And conceptually, if you actually look at all the join operation, this is a good picture. Inner join is that where everything has to match in the intersection. Left join is everything in the left table. Right join is everything in the right table. Outer join is everything that is in the union. So if there's nothing matched on the right, you also show the record on the right, and then setting the non-matched ID to be empty. And there's also more fancy ones, left excluding join, right excluding join, outer excluding join, and so on and so forth. Any sort of combinatorial structure you can find a join operation. Now, once you have done the join operation, you have created a new table. What you can still do is actually you can do the operation as group by. So you've seen group by operation in data frame. So this is very much basically using the Panda data frames group by operation of the results coming from my SQL query. So again, if you look at this SQL query, I'm going to select album ID, and I'm going to use this operation count. So I'm just going to look at for a specific album, how many tracks are there? And then I'm going to group them by album ID. So if I actually do this, it's going to say, well, a specific album has, this one has 10 tracks, this album only have 3 tracks, this album only have 8 tracks. So if you want to combine, want to see a little bit more information, right? Here I'm just counting, but it's not very informative. I can now do a joint operation. So I'm going to select from the track table the name of the album. I'm going to count the number of tracks. Now I'm going to combine this table using inner join with the album table such that the album agree, and then I'm going to group by the track ID. So this is now became a more involved SQL query. And what you get is to say it's going to return the album name and it's going to return number of tracks. So again, this is a very similar operation when you're using data frame to operate on tables. You're just counting number of tracks for each album. But this is achieved by 3 specific syntax: the count operation, inner joined operation, and group by operation. So again, you can in this particular case, remember we can use where to put specific condition over the record. You can also use what's called having, which is a specific keyword, which works like where. And the difference between having and where is like a filter, but having is performing some form of aggregation. So in this specific case, everything else is the same up until here, where here we're just going to say, I'm going to have all the track, the count to be bigger than 15. What does that mean? That means I'm going to only return the albums which has more than 15 tracks. And if you see here, it just says all the album here has at least 15. So you're seeing 17, 18, 34 tracks. Well, I have no idea what this album is. It has 34 tracks. Must be ours. So anyway, let's move on. If you actually look at, again, everything here is the same, but also I can change my filter function here, having number of tracks bigger than 15. But specifically, what we have done is we actually rename this particular variable and make it easier to use. So for example, in the previous one, we're using, the tracks.track ID, which is a specific column in a specific table, but we basically rename it when we select that table as number of tracks. So what you have done here in the syntax is I am counting number of ID and rename this number of count as a new variable, which is NR tracks, which basically corresponds to number of tracks. And as this new variable, you can use it to filter my records. And it's going to produce exactly same results as before. There are other specific syntax you can use, things like average, max, and sum. And in this particular case, we're giving example of using those aggregation function to convert millisecond to minutes. So the first part of the syntax is I'm going to select the album ID, album title, and I'm going to count number of tracks. Then I'm going to take the millisecond column divided by 1,000 divided by 60, which converted to minutes. Take the max, convert it to the max minutes, and again, take the sum. So I'm computing the average in minutes, max in minutes, and sum in minutes. And then the rest is the same. And then finally, it's going to order by the average. And that's what you get. So in this specific case, you are ordering them by average. So it's sorted order by average, and everything is converted into from milliseconds to minutes. So again, you can actually use those syntax, average, max, sum, to do simple statistics over the table you're querying from. All right, the last bit is actually my favorite example for, well, it's a little bit mischievous, but if you ever seen this kind of very nerdy thing, comic, it says, did you name your son Robert? Drop table students, da da da. And because of that, they lost all the students' record. All right, what does this mean? When you actually execute a database query, you have to be very careful how you design your database. One of the very dangerous things to have is to allow user to have part control over the SQL query is executing. For example, you want the user to be able to say, I want to query all the album so that the user will provide a specific title. And this looks fine. So if user says, use your illusion 1 as an album title, then I can execute this SQL query as select everything from album where the title is equal to the user provided title. But the problem is this leads to what's called SQL injection. meaning that a mischievous user can actually play with the title of the album because you are using execute script to actually perform operations that is you don't want them to perform. For example, if first of all, let's look at the table. And this is everything in the database. So SQLite master, where type is table ordered by name. So this is just to say, okay, in my database, I have all these tables. Remember, we have certain tables: album, artist, customer, employee, and so on. Now, a mischievous user can say SQL. Well, actually, I don't want to do that. If I do drop, okay, here. If I say SQL, the title is equal to A, drop table invoice items. This is still part of the syntax that you allow the user to provide. So now if I actually print this user input and title, it's going to execute the specific SQL query, which is match title to whatever title, I don't care. Is the title equal to A? But the most important part that is being injected into my SQL query is drop table invoice item. What this does is going to delete that specific table from your database. Okay? So indeed, if I actually execute this, well, it looks like, oh, there's a bug. But actually, even though it didn't find the specific thing you're looking for, and then there's a unrecognized token, whatever, it does not prevent the underlying code to actually delete that specific table. So the table is actually gone. Remember, I'm going to delete the invoice item table. And if I actually displace it, previously I have invoices and invoice item, but now I actually have successfully deleted an entire table from your database by doing SQL injection. All right, so this is why we have this backup file, because I have already deleted a table from your table, so a table from your database. So later on, if you want to rerun this whole lecture, make sure you replace the table with the backup database. So the number one rule is to avoid using things like execute script, because this does not prevent SQL injection. So instead, you are going to use this question mark for substitution and pass in a tuple. So this specific case, I'm going to use execute again, where I say title is equal to what? In this specific case, even if the user inject this title, it's only going to sort of try to execute the first part of it. So in some sense that, in this case, I want to also drop the table playlist. But if I should display that playlist, the playlist is still there. So I prevent the user from actually trying to execute additional SQL command. So that's what this question mark is saying, is that I only want to execute the first part. So here is sort of more safe code, is that the entire safe code is I'm going to execute SQL query and I'm going to use title equal to question mark to force only executing of the first part of the command. And that is a very simple, naive safeguard of this, and but it's a good start, right? So this is not guaranteed to make your code completely secure, but at least that's the beginning of it. Hence the comic. All right, so what I'm going to do now is that any questions regarding databases so far? So what I would like you to do now, given the time we have left, actually I have quite a bit of time left, is that I would like you to go to the exercise part of this. So if you recall, we're towards the end of the semester, everybody have to submit 5 activities, all right? So if you have not done that, please start going back and do at least 5 activities and submit through Canvas, because that's how you get the 5 points towards your final grade. So I'm going to let the rest of you to form, for people who are remote, I'm going to put you into break rooms. And for people who are here, you can form 1-person team, oh, sorry, 2-person team or 4-person teams to try to do those SQL queries on your own. All right. Any questions before I stop streaming? All right. I think we're good. So stop.